Hello again, scholars. I'm very sad to learn that the audio cut out in my example from the concavity video. So this is, how can I find all points of inflection of y equals e to the negative x squared? I promise to double check the file before I post it. So I'm going to move to sort of a blank screen. What am I going to need to do to find the points of inflection of this function, y equals e to the negative x squared? Well, points of inflection occur where the second derivative changes sign. So I'm going to start by finding y prime. Then I'm going to find its derivative, y double prime. I'm going to make a sign chart for y double prime, and I'm checking for places where y double prime changes either from positive to negative or negative to positive. So what I really need is y double prime. Of course, I'm going to have to start by finding y prime. The derivative of e to the negative x squared is e to the negative x squared times the derivative of that exponent, which is negative 2x. So now when it's time to find y double prime, I'm going to need to use the product rule. So the derivative of e to the negative x squared times the quantity negative 2x is going to be, let's see, the first times the derivative of the second, plus the second times the derivative of the first. Oh, I've already found this derivative, e to the negative x squared times a negative 2x. And so in order to make one of those sign charts, remember that the place I mark on this number line, this is a sign chart for y double prime, so I'm going to write that. The place I mark on that number line are places where this function, in this case y double prime, equals 0. And my best bet for finding solutions to an equation like this, something equals 0, is to make sure I have 0 on the one side and factor so that I can use the zero product property. So I notice that e to the negative x squared is a common factor. I'm going to collect together the remaining factors. That's a negative 2 plus negative 2x times negative 2x is a positive 4x squared. I'm not sure what I said, so I'm going to say it right here. If I said it wrong the first time, you'll forgive me. This is e to the negative x squared times the quantity negative 2 plus 4x squared. So I'm going to write myself a little note. This whole product is going to equal 0 if e to the negative x squared equaled 0, or anytime that negative 2 plus 4x squared equals 0. That's what the zero product property tells me. So I remember that an exponential function like this one, e to the negative x squared, there's no value of x I could replace. There's no value I could replace x with. It would make this exponential function 0. So this is going to have no solutions, and I'm going to end up, the only solutions I'm going to have, this numbers I'm going to mark on this number line, are solutions of this equation. So there's lots of different ways to rewrite that. I might like to factor out a 2, and this, I might like to factor out a negative 2, and this is 1 minus 2x squared equals 0, which I'm going to factor 1 minus radical 2x and 1 plus radical 2x. So this now I now have 3 things multiplied together to equal 0. But notice negative 2 is never going to equal 0. 1 minus 2 square root of x is going to equal 0 when x equals 1 over square root of 2. And I have a second root, which is going to be the opposite of 1 over square root of 2. So I have 2 solutions, positive and negative, 1 over square root of 2. I'm going to mark them on my number line. If it's important to you to rationalize that denominator, feel free. It's not that important to me. So it turns out what I really have here, my second derivative, I want to know when my second derivative is positive, when my second derivative is negative. I can test a point from each of the 3 intervals that those 2 solutions divide my number line into. I suppose a 0 would be an easy one to test. This is going to be, oh, it's much easier when it's factored. If I use 0 for x, I'm going to have e to the 0 is 1, negative 2 plus 4 times 0 will give a negative result. I think you will find when you test some values, you have a positive result for that piece of the number line and a positive result there. So I have two solutions of the equation y double prime equals 0. I've marked those two solutions on a number line and checked a point from each interval. The question here, back to what makes a point of inflection, my original function y is going to have a point of inflection anytime the second derivative, y double prime, changes from positive to negative or negative to positive. So notice that in fact, I do change from positive to negative at that root, and y double prime changes from negative to positive at this root. So I will write up my final answer. So my final answer, y has points of inflection at x equals positive and negative 1 over square root of 2, because y double prime changes sign at those values. You could choose to be more specific. You could say because y double prime changes from positive to negative at x equals negative 1 over root 2, and from negative to positive at positive 1 over root 2. But it's not required. We just need to specify that we recognize we did enough math that we believe that we've shown that y double prime changes sign at those two places.